Hi guys, welcome to my YouTube channel, and in this video we are going to discuss the permanent dipole charges as well as hydrogen bonding. So the permanent dipole forces, they are normally present between two molecules which have permanent dipole forces. So a fine jet of polar molecules will always be attracted towards an electrically charged plastic rod or a comb, which you can charge by rubbing it with a wooden piece of cloth. And the molecules are always attracted to the rod, whether the rod is positively charged or the rod is negatively charged, basically because they have both the positive charge and the negative charge ends. So the forces of attraction between these two molecules are called the permanent dipole forces. So it is normally force of attraction between a negatively charged molecule and another molecule with a partially positive charge. So for example, if you have propanol, which has a partially positive charge on carbon atom and partial negative charge on oxygen atom with another propanol molecule, there is always a weak permanent dipole force between the one propanol and another because of attraction between the partially negative oxygen charge and the partially positive carbon on the next atom. So you find that these molecules with a permanent dipole charge, they have stronger or higher boiling point than the other molecule which have the temporary forces of attraction. For example, butane and propanol. Propanol has high boiling point because it needs a lot of energy to break the permanent dipole forces of attraction. Then we look at hydrogen bonding, and hydrogen bonding is formed. Hydrogen bond is a bond that is very strong, and it is the strongest intermolecular bonding, and it's normally a type of a permanent dipole bonding. So the hydrogen bonding occurs between two molecules which have a hydrogen atom covalently bonded to an electronegative atom, that the atom that pulls away electrons from it. That's, for example, fluorine, oxygen, or even nitrogen, which are very electronegative atom, and another molecule which has an electronegative atom but it has a lone pair of electron. For example, the one that is displayed there, we have a nitrogen atom bonded to hydrogen, and between the two molecules, and another nitrogen atom bonded to hydrogen, but it has a lone pair. That force of attraction between hydrogen and another molecule, for example nitrogen with a lone pair of electron, it will form a hydrogen bond, which is very, very strong. So the force of attraction between a hydrogen and another molecule that has a lone pair is usually very strong, especially if the bond angle is 180 degrees Celsius. The bond angle is 180 degrees Celsius. So hydrogen bonding is also present in water. Hydrogen bonding is also present in water, and you find that water molecules have a hydrogen that is bonded to hydrogen, that is two hydrogens bonded to an oxygen with lone pair of electrons. So in a water molecule, it can form two hydrogen bonds with two other hydrogens, a hydrogen bonded to the one lone pair and another hydrogen bonded to the other lone pair. So you find that the average number of hydrogen bond formed per molecule will depend on the number of hydrogen attached to either the electronegative atom, either fluorine, oxygen, or nitrogen, and the number of lone pairs that are present. So for water, it has two lone pairs of electrons, and therefore it can bond to two other hydrogen atoms, forming a very, very strong permanent dipole forces. So water is extensively made of hydrogen bonding that are very strong. Ammonia has the less number of hydrogen bonding because it can only bond with one hydrogen, or it can only form one hydrogen bond with a lone pair of electrons, because it has only one lone pair of electrons.